Last week we did derivation of the escape velocity, but today we're going to solve problem on escape velocity and velocity of a satellite. The first example, now we have to look for escape velocity, and the formula for escape velocity equals to square root of 2GRE. That what we derived in the last class. And you have 2 times, you are giving eccentricity to gravity 9.8 multiplied by the radius of the earth, 6.4 times 10 to the power 6. When you do the multiplication very well with your calculator, what you get is 11 times 10 to the power 3 meter per seconds. Escape velocity, therefore, 10 to the power 3 is kilometer per seconds. That's the expression, that's the value for escape velocity. Now, example 2. For a satellite, which is close to the Earth's surface, its radius of orbit may be assumed to be equal to the Earth's radius. Earth's radius R equals 6.4 times 10 to the power 6 kilometers. Estimate A, the speed of the satellite. B, the period of rotation of the satellite. This is the question. We're going to go into solution. We're going to go into solution of the problem. Now, first thing to do, to bring out the parameters. The radius of the Earth, 6.4 times 10 to the power 6 kilometers. Take notes, eccentricity to gravity is 9.8 meter per second squared, and we have to look for speed of the satellite, and we're looking for period t of rotation of the satellite. In the last class, we made derivation of the velocity, the speed of at which the satellite moves, so because the square root of GRE. Just make your substitution direct. 9.8 times 6.4 times 10 to the power 6. When you press your calculator, you have 8.0 times 10 to the power 3 meter per second. Take note of the units. Now, we have an expression for angular velocity. An expression for angular velocity will be equal to 2 pi f, where f, which is the frequency in hertz, equals 1 over period. Make a period the subject of the formula. When you cross multiply, you have ft cross multiply equals 1 divided by f. F cancel f. You have t period equals 1 over f. You make your substitution. Angular velocity equals 2 pi times 1 over t, which is equal to 2 pi over t. Now we have angular velocity over 1, which is 2 pi over t. When you cross multiply, you have wt. W times t equals to 2 pi. By looking for period, divide by angular velocity. Now have your t equals 2 pi over angular velocity. And don't forget our w, our velocity equals omega r under simple harmonic motion, and we are looking for w divided by r, so that radius will cancel out. W now equals v over r. You substitute angular velocity as v over r. Go back to your period. T equals 2 pi. Instead of writing angular velocity, you introduce v over r, which is equals 2 pi over 1. Don't forget v over r, they are moving together. V over r. Change division to multiplication. Radius will go up. 2 pi over 1 times r over v, which is 2 pi r over v. Substitute your value, 2 pi times the radius. You have the radius of the earth to be 6.4 times 10 to the power 6 divided by velocity. I go to your first calculation, 8.0 times 10 to the power 3. Your period now, t, equals, when you multiply 2 pi times 6.4 times 10 to the power 6, after pressing your calculator, you have 5 times 10 raised to the power 3 seconds. That's the period of rotation of the satellites. I'm going to stop the calculation at this point. We move to the next topic in the next class. Have a nice day. Thank you.